Hello and welcome to another pre-calculus video. In this one, we're going to look at some problems to get us ready for the test coming up on 5-4, sum and difference formulas. So let's dive in. So here we got the first one. Now notice we're not finding the sine and the cos and the tan. In this case, we only want the sine of 285. And if 285 was on the unit circle, that would make this problem very easy. We just get that y value off the unit circle. But 285 is not one of our friendly angles, so we break 285 up into 315 minus 30 degrees. Okay, so we now have this as the sine of a difference. So the pattern for sine of a difference is going to be sine times cos minus cos times sine. And I'm just writing this out with the empty parenthesis. And we drop in our angles in the order, 315 first and then 30. So this is a 315 and then a 30. And after the minus sign, we have another 315 and another 30. And now we go to the unit circle. The sine at 315 here, that is a negative root 2 over 2. And we're going to multiply that by the cos of 30. And the cos of 30 is root 3 over 2. And then we got our minus sign. The cos at 315, that is root 2 over 2. And we're going to multiply that by the sine of 30, and that's 1/2. So I'm going to work my way up here. So we are going to have one fraction, and our denominator, over here we have a 2 times 2, so that's a 4. Same thing over here, 2 times 2 is 4, so our common denominator is built in, and it's a 4. The first piece of our numerator is this, and if we multiply those together, we're going to get a negative radical 6. And then we've got minus, and then here is root 2 times 1, so that would just be the root of 2. And there is a perfectly acceptable answer to this. And just for the sake of argument, let's say you're taking a standardized test and it's multiple choice. You might see this as an option. You know, if we factor out a negative sign, we now have a negative out here, and then we would have root 6 plus root 2. So there's number 1. We found the sine using sine of a difference in degrees. Now here is, get back there. We're going to find the cos of this angle, which we have broken down as 11 pi over 6 plus pi over 4. So now we're going to use the cosine pattern, and the cosine pattern is going to be cos cos, and then followed by a sine times sine. And here we're doing the cos of a sum, and the formula tells us that will be a minus here. And then we drop in our angles. 11 pi over 6 goes first, and then a pi over 4, and then another 11 pi over 6, and a pi over 4. All right. Cos of 11 pi over 6, that is root 3 over 2. Multiply that by the cos at pi over 4, that's root 2 over 2. Subtract. The sine at 11/2 pi is a negative 1/2. And the sine at pi over 4 is root 2 over 2. So once again, our final answer will be a single fraction. Our common denominator is again 4. And now our first piece of the numerator, if we multiply these together, we're going to get a root 6. Now here, if we multiply these, we're going to get a negative root 2, but it'll hit this negative and turn to a positive, plus a root of 2. And there's our answer for the exact value of the cosine of 25/12 pi. Up next, now we're going to go backwards. So now we've got the expanded form. We want to condense it down. And let's see here, our pattern is sine cos, cosine. So that tells me it's going to be a sine. And if we're doing a sine, we keep this same symbol here. So this is a minus, this will be a minus, and then we can drop in our angles. First in goes a 60, next goes a 45. 60 minus 45, last I checked, is 15. So the sine of 15 degrees is the same thing as all of this. All right, now we're going to do the set up the triangles one. So we've got u and v, tan of u and cos of v, and we can see their values right here, tan u, cos v, and they just explicitly tell us what quadrants we're in, so we're in 1 and 3. So first I'm going to set up my u triangle. I'm going to use red for that. U is in quadrant 1, so I'm going to draw out into quad 1 and back to the x-axis. Angle u is right here. And for u, we've got tangent. Tangent is opposite over adjacent, so opposite side 3, adjacent side 4. A little Pythagorean theorem will tell you the hypotenuse is 5. So there is our 3, 4, 5 triangle. V is in the third quadrant, so I'm going to draw a third quadrant here. We go out from the origin and back to the x-axis. That will be angle V. And the cos of V is -4/5, and that is adjacent over hypotenuse. So our adjacent is 4, hypotenuse is 5. And because the origin is right here, if we move to the left of the origin, that means the negative is going to be attached to the 4. So let's see here, we need the missing side. It is going to be a 3, but remember here we're now going down below the x-axis, so that 3 is also going to be a -3. All right, let me move this up here so I have a little more room. Now I'm going to just write out the expansion, sine of a sum, sine of a plus. So that's going to be sine u, oop, that's a terrible cos, sine cos plus cos sine v. Now the things they gave us are usually going to be part of this puzzle. Well, actually up here, no, not tan. We can't use tan of u anywhere because there's no tans down here. But we do have a cos of v. Cos of v is -4/5. So this cos of v is -4/5. So now the rest of these pieces we're going to have to get from our triangles. So this one here, we've got the sine of u. That's the red triangle. Sine is opposite over hypotenuse. So that will be a 3/5. Now over here, we've got a couple more. First, we got to go to the u triangle and find the cos at u. The cos at u is adjacent over hypotenuse. So that's 4/5. And then finally, the sine of v, we come down here to the blue triangle. Sine is opposite over hypotenuse, so that's going to be a -3/5. Okay, let's see what our final answer is going to look like. Let's see, we do have the common denominator. To the left of the plus, we have a 5 times 5. To the right of the plus, 5 times 5. Denominator's 25. Our first piece of the numerator is 4 negative times 3. So that's -12 plus. Here we have 4 times 3. Ooh, I missed. This is a -3/5. My bad. Sine of v opposite over hypotenuse, so that is a -3/5. So here, this numerator is also a -12. So we have -12 over, or -12 plus -12 all over 25. That is -24/25. Our exact answer for the sine of u plus v. All right. Okay, now for a couple easy ones to wrap this up. First, we're going to verify the identity. Remember here, we're making the left side look like the right side, so that's our finish line. And on the left side, we have the cosine of a sum. So what's the pattern for cosine of a sum? That's going to be cos cos minus sine sine. Cos cos minus sine sine. And we drop in the angles. First goes an x and then a half pi. X, pi over 2, x, pi over 2. So we simplify the terms we can with the unit circle. Cos of x, that's still got a variable in it. We don't know what's going on there, so that'll just stay a cos of x. The cos at a half pi, well, that's equal to 0. So we're going to multiply that cos x times 0. And then here we've got minus sine x. And then the sine at a half pi, that's the top of the unit circle. Our sine value is a +1. So 0 times cos wipes that term out. Don't lose track, we still got this negative here. So this is negative sine times 1, or just negative sine x. And that is our finish line. So we made it. Congratulations. Now the last one is very similar to this, but we don't know the finish line. We're just going to simplify. Simplify the expression algebraically. Let's see here. So, it's the same pattern, cos of a sum. So that's going to be cos cos minus sine sine. And the angles fall in. We've got a pi first, x, and then another pi, and another x. So the cosine at pi, that's our x-coordinate at pi radians. That is -1. And we're going to multiply that by cos x, which we don't know what that is, so we'll just leave it as cos x. And then we've got minus. The sine at pi is 0, and we're going to multiply that by sine x. So 0 times anything is 0, so this term just gets wiped out. And we've got -1 times cos, and that is equal to negative cos. So back here's our original statement. What is the cos of pi plus x the same as? It's exactly the same as negative cos of x. And that is the last problem on the practice test. Make sure to study up on these types of problems for the real deal. It's coming soon. I hope this video was helpful.